Hey guys, welcome to another video on Leetcode challenges. Today's problem we are looking at is longest common subsequence, also commonly known as LCS. So given two text strings, we are to find a longest common subsequence. By subsequence, it means it can skip over some of the characters in the text itself to match other characters in the other text, right? So given this example, you have this A matching the A character of other text2, right? C matching C here and E matching E here, right? It is not a substring, okay? So it is a subsequence, right? Let us see if we can solve this problem by solving some of the subproblems in the question. So let's say if we were to find LCS of A, B, C, D, E and A, C, E, right? Can we do it by finding longest common subsequence of A, comma A, or even LCS of A, B, C, D and AC, right? Something like this. There will be more smaller problems. If we can solve those problems and get an answer, then somehow we can construct an answer for the whole text itself, right? So let us figure out what all subproblems the the given text actually depends on. Let's say A, B, C, D and AC, right? If we were to have this solution, then we know that the last character of the text matches, right? So if we have this solution, this plus one for the match character can be a solution, can be our solution to the actual LCS for the whole strings, right? What about other subproblems? We also know that ABCD and ACE can present the solution for a longer string in text1 with an E, but text2 is already accommodated for. This can be one of the potential solutions for the whole problem itself. Another potential solution can be ABCDE and AC. So we see a pattern here, and I will draw the patterns for you to comprehend this solution. So let's say a text1 is this, and text2 is a string here. Now, what I will do is, our LCS, I will represent my problem LCS in the form of the indexing on these two strings. Okay, and I'll call ith index and jth index for the text1 and text2 correspondingly. Okay, so LCS of I and j will represent my longest common subsequence in text1 and text2, where text1 is just up till ith index and text2 is just till the jth index, including I and jth index, right? So if I have this answer, right, I can compute this answer by already computed previous answers. So let's see. Okay, so this depends on LCS of I minus 1 and j, right? So if I were already solved this problem, that LCS of I minus 1 and j, then I couldn't do any more thing with the ith character itself because there is nothing to match after j, right? So same goes the other way around, and we can even discard the ith and the jth character itself, right? So LCS, and since we are finding the longest common, I will match over all these three. Now one thing to note is, if my ith and jth characters are equal in the text1, so if text1 of I is equals to text2 of j, right, then actually I have a matching, which means my subproblem I minus 1 j minus 1 plus 1 could have been the answer for I comma j, right? So I also do maths on my I comma j and this whole another solution. Now that we have formulated our conditions for I and j, what we need to do is now run our algorithm for each of the ith and jth character in text1 and text2, right? Loop over them, memorize the already computed results, and return the answer for the last characters in text1 and text2. So let us look at how to do this in code. Let us take length into a variable because we need to loop over them again and again, right? Let us declare our LCS and initialize to 0 for I in range M, for I in, sorry, J, and for I in range N, right? So this is our store of computed results, right? This is where we'll store the results. And let's loop over I and J and compute the LCS, right? So LCS of I and J, first of all, I told you LCS of I comma J, LCS of I minus 1 J, right? LCS of I and J minus 1 and LCS of I minus 1 J minus 1, whatever we can, or all the possible 4 combinations, right? Now we also need to make sure text1 of I is same as text2 of J, right? Then we need to accommodate one more condition, that LCS can be max of LCS, current LCS, and LCS of I minus 1, J minus 1 plus 1, right? And in the end we return LCS of N minus 1, M minus 1. Okay, great. There is one problem that a lot of times for 0th row or 0th column we are doing I minus 1, J minus 1 calculations here. But in Python it might be okay because we can index list in Python using negative numbers, is basically wrap around from the end. So it might give you great results. But a better trick I have found over the years, doing the DP problems, is basically whenever you have the -1 computation, just initialize your memory to have another column and row. So you would initialize your memory or the LCS computation for M plus 1 columns and N plus 1 columns, right? Now your first row and the first column will always be 0. Okay, these are like your temporary guards against the negative indexes. So you will run your actual solution from 1 to N. So 1 to N, right? And your actual columns would be 1 to M. Okay. Now, since our I and J is 1th indexed, we just need to check here for text1 of I minus 1 and text2 of J minus 1. Right. Now the negative index on LCS is taken care of by a temporary added 0th column and 0th row. Okay. Now we also need to actually return the last 1th index last cell, which is N comma M. Let us try to summon this solution. Okay, great. Okay, here we are using time complexity to be order N into M, and our space complexity is order N into M again. But we can reduce our space to just use order M, just the columns, or whichever is shorter, whichever text1 or text2 is shorter. And why can we do this? Because we just need to remember the last row. Here we are using LCS of I minus 1. We just need to remember the last row values to compute the current row values for the LCS, right? So it's very simple to convert this code to using just one array. Just carefully look at what I'm doing right now. Okay, so I've removed from the LCS all the row representations. Okay, now my LCS actually represents all the column. Okay, so what I'll do is I'll go into LCS and remove all the row that is the ith position indexing. Okay. Okay. Now we need to take care of I minus 1th index, which means this is the memory that we have already computed, right? So what we need to do is we need to declare another array for the same column, and this is our previous row's memory. So this memory is the store of already computed results, and our LCS becomes current row computed results. Okay, so this represents memory represents the I minus 1th row, and our LCS happens ith row. Great. Now what we can do is wherever there is LCS of I minus 1, right, we can just replace LCS of I minus 1 with memory. So here LCS of my I minus 1 goes to memory. LCS of I minus 1, we can replace it with memory. LCS of minus 1 replace with memory. Okay, now we need, whenever we switch rows, we also need to remember to put all the current LCS values into memory. So our LCS, our memory becomes current LCS, and we just need to initialize our current row with zero values computation. Okay, and then in the end we have to return memory of m. Okay, let's try to run this code. Let's try to run this code. Okay, great. Thanks again for watching our video, guys. Please like our videos, comment what additional things you want in our videos, any other problem you want to be solved on Leetcode. Subscribe to our channel because we are posting more or less daily videos right now because of the current ongoing Leetcode challenge. Thanks again for watching. Please subscribe to our channel and keep talking. Thank you so much.